A few days ago there was a rocket launch in Fortnite, which kicked off a series of strange events. This has got some in the Fortnite community talking about physics. Ali A did a great video explaining how the visitor modified the film set rocket so that it could get him back to his home. I will link to his video below. It's not clear whether the visitor comes from a different location in space, time, or some other dimension. The first thing I would like to do is listen to the radio transmissions broadcast shortly after launch. There is some debate about exactly what is said. I will run the broadcast at different speeds so you can decide for yourself. I got the video clip from YouTuber TF141Ghost, and as always, the links are below in the description. Let's just assume for now that the message is 0-point oscillator on, set coordinates, engaging quantum field accelerator. This certainly gives us an excuse to talk about quantum physics. I'm not trying to decode or explain the propulsion system. Instead, I would like to give you a useful background to quantum theory. In the process, we will encounter spooky action at a distance, which may help to explain the recent crossover of items from Fortnite into the real world. First, let's look at that word quantum. In the legal profession, this word means a required or allowed amount. The use of the word in physics is similar, in that particles are only allowed to carry multiples of a certain unit of energy. It's as if energy is being carried around in packets, like 1 pound bags of sugar, only much, much smaller. In 1894, a German physicist called Max Planck was working on a problem called black body radiation. He had been commissioned by electric companies to create maximum light from light bulbs with minimum energy. On 14th of December 1900, he presented what is now known as the Planck postulate, that electromagnetic energy could be emitted only in quantized form. In other words, the energy could only be a multiple of an elementary unit. This is also known as quantum theory. Written E equals h nu, this simply means that the energy E is equal to Planck's constant times the frequency. When talking about light, the frequency is another way of saying the colour of the light. Radio waves have low frequency, followed by microwaves, visible light, X-rays and so on. X-rays and gamma rays have high frequency, and therefore their quanta would have higher energy than radio waves. In physics, the word quantum is used for the singular and quanta is used for the plural. Max Planck won the Nobel Prize for Physics in 1918. I think it's fair to say that physics started to get weird at this point. It's probably time to introduce Werner Heisenberg. In Breaking Bad, Walter White chose Heisenberg's name, so you can imagine that he's pretty important. In 1927, Heisenberg published the Heisenberg uncertainty principle. He was awarded the 1932 Nobel Prize in Physics for the creation of quantum mechanics. In quantum mechanics, the uncertainty principle is any of a variety of mathematical inequalities asserting a fundamental limit to the precision with which certain pairs of physical properties of a particle, known as complementary variables, such as position and momentum, can be known. Another way of thinking about this is with the quanta we talked about earlier. Say you're trying to observe the position of a particle very accurately. If you use low frequency waves, like radio, then you can't observe the particle as accurately as with high frequency, like gamma rays. So, you fire gamma rays at the particle, but because energy is equal to Planck's constant times frequency, the gamma ray photons carry a lot of energy. You can only observe the particle by bouncing photons off it, so you will change its momentum significantly. Hence, accuracy in the measurement of position results in uncertainty about the momentum of the object being observed. We're getting quite close to explaining recent events in Fortnite, but first we have to meet Erwin Schrödinger, an Austrian physicist famous for the wave equation. The way to picture this is as a way to describe the probability of finding a particle at a particular point in space and time. You may also hear the term wave function. Physicists sometimes say that when a particle is observed, the wave function breaks down and the particle is then observed at some particular point. Before this, the system is said to be in a superposition state. For example, imagine a particle being spread out so that it's in all places at once. The probability of finding it in a particular location is described by the wave function, which is the Greek letter psi in the formula. In 1935, after extensive correspondence with Albert Einstein, Erwin Schrödinger proposed what is now known as the Schrödinger's cat thought experiment. A cat, a flask of poison, and a radioactive source are placed in a sealed box. If an internal monitor, e.g. Geiger counter, detects radioactivity, i.e. a single atom decaying, the flask is shattered, releasing the poison which kills the cat. One interpretation of quantum mechanics implies that after a while, the cat is simultaneously alive and dead. But when you open the box in the real world, the cat is either alive or dead, not both. This poses the question of when exactly the quantum superposition ends and reality collapses into one possibility or the other. This brings us to the EPR paradox or EPR article, which may have some direct relevance to recent events in Fortnite. The Einstein-Podolsky-Rosen paradox, or the EPR paradox of 1935, is a thought experiment in quantum mechanics with which Albert Einstein and his colleagues Boris Podolsky and Nathan Rosen claimed to demonstrate that the wave function does not provide a complete description of physical reality. Imagine two particles which are created together and then head off in opposite directions through space. This happens a lot in physics. To avoid getting too deep into particle physics, let's assume that if particle A is black, then particle B must be white. If particle A is white, then particle B must be black. But until they are observed, particle A is both black and white, i.e. it is in a superposition state, and so is particle B. The problem here is that when you observe particle A, the quantum superposition ends and reality collapses into black or white. At exactly the same moment, the other particle, which could be millions of miles away by now, also breaks down into the opposite state. You've sent information between the two particles faster than the speed of light. This has come to be known as spooky action at a distance. The intention of the EPR article was to show that extreme interpretations of quantum mechanics are not compatible with our understanding of how the universe works. However, experiments have since shown that spooky action at a distance may well be real. This may help to explain why objects are disappearing from the world of Fortnite and reappearing in the real world. On the 6th of July 2018, Twitter user Sela Shaloni posted photo and video from a desert in the USA showing the Durr burger head, which disappeared from the game. Other landmarks are disappearing and may turn up elsewhere in the real world. Watch this space. If you are in the unfortunate position of having watched this video all the way to the end, please like, please subscribe, please ding the bell, and we'll do it all again on some other subject. Thanks a lot. Bye.